there's some people who dedicate themselves to researching whether dark matter exists and how you have presumed the existence of dark matter and then gone ahead with your calculation. So if you could develop that.
So very quickly, just maybe a quick reminder what dark matter is, like what we mean by that, right? Is that essentially the world around us, the world we see, is constituted of particles that are known as baryons, and they're visible, right? They interact with light. This is why you see things, right? So stars are visible, planets are visible. All of this is made of regular baryonic matter. But over the last half century or so, maybe a little bit longer actually now, we've become aware that visible matter does not explain a number of things. Like that essentially, if we want to explain, for instance, the way that distant stars move around the galaxy, the way that galaxy clusters evolve or are in equilibrium, in order to explain these data, we need to include a new component, right, to our description of the universe, and this component is known as dark matter. So basically, dark matter is one of those words like dark energy, or where essentially we're admitting that we don't know what it is, we just know what it isn't, right? So we know that it's dark, so it doesn't interact with light, with electromagnetic radiation in the way ordinary matter does, and that's all we know about it, right? We know that it has no interaction with light, and we know that it has mass because it interacts with the gravitation. It interacts gravitationally, right? So just for a bit of history, the way precisely we discovered dark matter is that we were looking at the way that stars move around the distant outer edges of a galaxy, and we realized that in order to explain the motion of these stars, there had to be some missing matter, right? There had to be some matter that we couldn't see that really explained the movement of these stars.